Hello everyone. Today we have the second production video. This is how we will make the ALUTECH SL160 sliding system. Be sure to watch until the end. It will be very interesting. We will break everything down in detail. Here we have the prepared sashes of the SL160 sliding system. We showed the cutting of the profile, processing, milling and corner connections in the previous video. There will be a hint here. The process is the same. We cut, milled and assembled the corners. This is the same process for all aluminum windows, so we won't show it again to avoid repetition. Now we will move on to the nuances that specifically relate to the assembly of the sliding system. Here, on the side of the installation of the double glazed unit, we have the same spacers, but they are specific for the sliding system. There are already 8 of them here. 4 are placed at the bottom and 4 at the top. So the installation of these supports differs from a regular window. This is a flange insulation. It is exactly the same insulation as in the window system, insulating between the double glazed unit and the sash. Next, what features do we have? For example, look here. We use star-shaped tightening brackets for torque screws at the corners. And these sashes, when we put it on and tighten it, it kind of connects the corner, compressing it together, resulting in a perfectly good connection. So, there are such things here. Next, a distinctive feature in the gallery is the presence of a large amount of insulation that is installed in the sash. In addition to this flange insulation here, pay attention, 2 additional insulations are installed at the bottom, which will press the sash against the lower frame. This is very important because it often drafts from below. Thanks to these insulations, there will be no drafts. They come with a self-adhesive layer, meaning they stick directly to the bottom of the profile. Next, we have insulation inserted into the groove here, as you can see, right? Then, a large insulation piece is inserted here. This is how it will be inserted. And then, a cover is placed on top of this sash. So, there will be a large thick insulation in that void.
This is what it looks like, just like this.
You see how thick it is? There is no space left here for any cold to form. Insulation is everywhere.
There is insulation at the top.
That is, we have maximally insulated this product everywhere. Next, pay attention to these plastic elements, which are quite sturdy. They are installed here at the top and bottom. They are needed for fixed sashes. That is, this is a sash that is assembled and will not move. It will not have any hardware installed on it. In order to position it correctly in the frame, it is necessary to screw these plastic elements, which allow for precise positioning, and then it will be attached directly to the frame with self-tapping screws during installation. Another advantage of the ALUTECH SL160 modular system. Each sash has these system-level adjusters called plastic ones, which are installed on both sides, here and here. What do they provide? During installation, when we place the sash on the frame, it is precisely positioned between these plastic elements. And the sash never rattles like this. It moves smoothly in pairs. In other cheaper systems, I have actually seen sashes come off the rollers, not working properly, starting to let in drafts and freeze. And here, these adjusters, though small, immediately enhance the quality of this system. It immediately becomes of higher quality, and there are many such details in ALUTECH. That's why the ALUTECH sliding system is really cool. At the junction of the 2 sashes where they engage, a plastic element is attached to the sash, which directly helps us achieve this engagement. Next, we have a milled cover with insulation inside. Here is a special plastic loading, and this area is additionally insulated with these well thought out items. Look, this lifts up like this. Why is this needed? Because when we insert it, this is the upper part and it will be constantly lifted. Accordingly, when our sash is lowered onto the frame, this little piece lifts up, preventing drafts in this area. This is also an advantage of ALUTECH. Not all systems have such draft preventing details. So here, drafts are excluded. Next we go down. At the bottom we also have a special element. It's also a plug into which this insulation is inserted. Accordingly, it will also lower onto the frame with this pinch, pressing against it. Therefore, drafts in the area of 40 are simply excluded. A very warm, reliable system. This is a frame of a sliding design. It's quite large. It is fully assembled at the factory for each sliding door. Of course, it is possible to connect everything on site, but these are very critical corner connections, and it is better to do this at the factory. It can even be connected here. That is, if there is a very large sliding unit, there is an option for a 180-degree connection in ALUTECH using a special plastic insert. All of this is sealed tightly. Next, look, the corners are cut at 45 degrees and connected with the same inserts as a regular window using a 2-component adhesive. All of this is compressed. It can be done either on a corner pressing machine or with special screws. Here we have used screws to tighten this corner. Next, here we have made 2 support profiles on which this sliding frame will rest from below. A warm support profile of the triatherm type, compact phone, and many different types can be used, and it can be of considerable height. That is, if we have a small height from the dirty floor, from the concrete, then such a support can be used. If there is a large height of 100-200 mm, then we specifically make such a large warm support. Next, we look at the milling of the lower frame. This is a very critical moment. Here, we have a plastic groove in which milling has also been done. There are millings both in the groove itself and under the groove, possibly for condensation to enter, so there are such through holes in this internal chamber. This is so that when a dew point forms and a drop of condensation may form under this plastic groove, it will drain into these holes that have been made. Next, this groove is installed. We do not install it in production because there are still places for fastening screws, special screws that are installed on site. In order for them not to be visible, so that it is a hidden fastening, the frame is first fastened and then this groove is installed on site. Water that enters here from the street passes through this milled hole. Then it enters these holes that we have made in the frame and exits to the street. Here we see 2 drainage holes. The first drainage hole is the one through which water directly exits from the groove through the upper one, and the lower drainage hole is another one. This is condensation that can form inside under the gutter and inside the chamber of this profile. And all of this is drained outside. In ALUTECH, the moment of water and condensation drainage is very well thought out. And notice that there are also these rubber elements here. This is what they look like. They put drill holes, and through the sealant this element is placed very tightly here. What is it needed for? It is needed so that we have a 4-leaf structure, meaning we have 2 outer and solid leaves and 2 central and movable ones. And when the central leaves move, water flows into the gutter, water flows from the street, and we need the water that gets here in a closed state to exit outside and not seep into the room, because this gutter, we see it from the inside, regardless. And this lower plug is a very important element. It limits the water that can seep into our room. It is very important to install it well with sealant. Next, another very important point. A stainless steel strip is installed on the guides along which the leaves move. It is directly driven in there. So we see a groove here, and in this groove, this stainless steel strip is directly driven in, along which the rollers move. This allows us not to wear off the paint, this coating, and the rollers move along the stainless guide, and in fact it will never get damaged. It will roll forever and nothing will happen to the profile itself. And it is installed only here because our leaves move only along the inner rail, while the outer leaves are solid on the sides, so here we are. We do not install any of this guide here. The leaves will be installed here. One on this side, the second on that side, and here in front of the inner movable leaves, a special threshold will be installed in which all the drainage holes are also made. And then we get a plane. The leaves are shifted and the water that gets through this threshold and the drainage hole goes outside. In general, everything is well thought out and planned. Verculae. We install a similar gutter, but it is indeed deeper. This is necessary so that the leaves can be installed. We slightly raise the welding and then do not start it during installation. Therefore, the gutter is of greater depth. A special element, insulation, is installed on top of this gutter. It is needed at the joint of 2 sashes to seal the joint area so that nothing can draft through. And it is inserted right here like this, from this side, from the end like this, and it stretches directly to the joint of the 2 sashes. Next, everything is measured and fixed here with self-tapping screws, and we get an insulated area here where neither air nor frost penetrates. Then this gutter is installed in the window during assembly. One more point. Here are such aluminum canopies. This canopy has a special shape. It is installed like this on the frame. And why is it needed? It is needed so that the water that flows from above and hits our product goes down this canopy to the sash and does not get into the joint between the sash and the frame in this gap. That is, it kind of covers the upper sash. This is a very important element. It protects against direct precipitation. It is installed on top. There is a similar element that is installed at the bottom. I will show it to you now. Here, so a similar element like the one on top, a kind of wing, is installed at the bottom. It is screwed to the frame like this, and it creates a plane on top, a clean floor with a guide. Why is it needed? It is needed so that you can approach the floor from the inside and outside. By default, it is installed from the inside to allow access to the clean floor. It is installed outside at will. In general, if we have the floor goes outside under the frame, then there is no point in this profile. If we want to sink the frame, we have that option. There is some terrace board and the water is drained underneath it, or there are special drainage gutters. Then we can completely sink the frame to the level of the clean floor, and we need these aluminum profiles on both sides so that we can approach the floor nicely, so that we do not hit the floor against the sash and the frame. And there was a clear line, so the practically last stage for us is the installation of fittings. Here we have the sash lying down. The fittings are called lift star. This is Hautau, a German fitting. How does it work? Here we have special rollers at the bottom on which the sash moves. The fittings lower and raise these rollers. That is, when I move the handle, you see the rollers also move. That is, when our handle is up, the rollers rise up and the sash lowers onto the frame. When the handle is down, the fittings place the sash on the rollers, lift it, and it rolls along this stainless steel guide that we installed on the frame. It fits right here into these grooves between the rollers. The rollers are connected by a long element, a special solid piece with a lock, and it directly drives all these rollers. Counterparts are installed on the frame, and they look like this. This part is small and one is elongated. I will explain why now. They are installed opposite these holes and they engage. So it just clicks and engages there. That is, it goes click, circ. Now we can't pull it out. This closes and locks, pressing the sash against the side frame. They are installed on the side frame. This element, which is slightly longer, is called microventilation on sliding sashes. When we engage our sash, not in the far position but slightly pull it away from the frame, while we don't want anyone from outside to be able to enter. Accordingly, we calmly lift the handle. It hooks on, creating a small gap, and that's it. No one can get in, but we have a slight microventilation. The handle here is without a lock. This option is possible when we install such a handle from the back, which I call a pull handle. So there is no long handle here, just a small handle that we pull. We often do this because if we install such a large handle on both sides, then a lock must be installed to ensure that no one can enter from the outside. To enter the premises, if you turn the handle, a lock must be installed. In this case, a lock is not necessary because when we pull the sash and turn it, it cannot be accessed from the outside. It can only be opened from the inside. Overall, this configuration is quite popular. The next step, the very last one, is the installation of the bead and packaging of these products. But we won't show this because we already filmed it in a previous video. It's all a similar process. So we have finished discussing the manufacturing of the lift and slide structure. I hope you liked the set and found it useful. We tried to share the most interesting highlights. There will be more to come. We want to film about folding doors and facade glazing. If you like this format, please support us. Give us likes and subscribe to the channel so we know for whom we are doing all this. Goodbye everyone.